Hello everyone, and welcome to this particular video where I want to talk about a very important concept related to linear regression. And this is basically the concept of variation in the data. So basically, whenever you're working with any data, our objective is often to try and understand the variation in that particular column. So for example, if you are building a regression model to explain a column Y, basically you want to explain the variation in Y. So at this point, let's take a moment and understand what is variation. How do you understand the concept of variation? So you might have learned about it, in your course on statistics, but I'm going to just reiterate it and share my perspective on the concept of variation. So basically, when we say variation in something, we often refer to the difference from a benchmark. In the case of data, when we talk about variation in a particular column, you're talking about the variation from the mean of that particular column. So as you might remember, mean is also called a typical value. A typical value is essentially representing an average profile, an average value in a particular piece of information. So variation is in context of that mean. So now what happens is that there are aspects of variation which can be explained, and then there are those which cannot be explained. So what happens is that we can break down the total variation into explained variation and into unexplained variation. So let's understand this with the help of this visualization. So I have this particular visualization here. Let me first explain the different pieces of information that are given here. So you have this y on the y-axis. This will be your target variable, and this is your x. And to make it simple, we've kept it two-dimensional for the purpose of illustration. And the blue line is basically your regression line. Okay. Now your y is your target variable. And the green line here, it represents the mean of y. And I'm going to represent it by y bar. So we're talking about this is your target variable. This is your x variable. The blue line is the regression line, and the green line is the mean of y. Okay. Now for an observation yi, so yi is an actual observation in the data. Let's say it's over here. Okay. And you see that the point yi hat is this estimated value. So yi is being estimated as yi hat on this particular visualization. Okay, but the total variation in y is essentially the difference in yi and y bar. Okay, so like I said, variation is always with respect to the mean. So when you see that yi has a particular value and y bar is the mean of y, you see the difference between them, that is called the total variation. Now, a part of that variation can be explained with the regression line, and a part of it cannot be explained. So you see that the explained part is this bottom part. So the difference between yi hat and y bar is the part of the variation which you can explain, which is here. And then there is a part which cannot be explained, which is here. So this unexplained part is basically your error, which is your yi minus yi hat. So I'm going to take this, explain this with the help of an example here. So suppose you were trying to predict the score of students on a particular test, and let's say the test is scored out of 100 points, and a particular student had gained let's say 90 marks. So yi is 90 and the average performance is, let's say, 75. Okay, so the total variation is 90 minus 75, and suppose you're able to estimate that with let's say 80 units. So what you're saying is that out of 90, you are able to explain 80 units, but 10 units difference you cannot explain. That is the error in your model. Okay, so the explained part is going to be the difference between the estimated value, which is your 80 units, and your mean value, which is 75 units. So the total variation is the difference between 90 and 75, that is 15 units. 5 units out of that you are able to explain with the help of your regression model, and 10 units you're not able to explain. Okay, so this is basically an explanation for the difference between the explained variation and the unexplained variation. Now let's see how is this used to measure the performance of regression. Now you all might have already heard about the statistic of R square, or the coefficient of determination. And the coefficient of determination is based on the same concept that I was just talking about. So what we are saying is that whatever is the total variation in the y variable, that is our target variable, a part of it we are able to explain. Okay, if we are able to explain a higher proportion of that variation, then our model is a good model. And a model that is able to explain a lower percentage of that variation is a worse off model. So basically, uh, here's how we represent that. Total variation is the variation in y that is explained by x divided by the total variation in y. So that is your R square. Okay. And in the terms of statistical formulae, this is how we represent it. We say that R square is the sum of square explained by regression divided by the total sum of squares. So what we can do is basically the total sum of square, which we often represent it as TSS, is the total variation in y. And we are able to explain or split that total variation into two parts. The first part, which is the regression sum of squares. So regression sum of square, often represented by RSS, is the explained proportion of the total sum of squares. And then we have the error sum of square, which is often represented as ESS, which is not explained by our regression model. So by using this concept, we can define R square, and higher the R square, the better is the regression. Okay, so this is a very important concept that you need to understand. I'm going to end the video here, and in the next video I will be talking about the assumptions of linear regression.